Hi, it's time for another math easy solution and discuss some more derivative rules. Look at the exponential functions. Part 2 of the series. I made part 1 a while ago, which I derived it using exponential functions, derived derivative using definition derivative. That was pretty complicated, but now we're going to use chain rule and it's much easier. So basically, exponential function is fx equals to a to the x, where a is a constant and x is a variable which we're changing. This is not to be confused with x to the a, which this is a power function. Yeah, just don't get confused with that. But so anyways, I showed in my other video. You can see the link below in the info section. Basically, how I got this. The derivative is equals to a to the x times limit h approaches 0 of a to the h minus 1 over h, or which equals to a to the x times f prime of 0. So a derivative of itself but at 0. So this is, well, this is really complicated. Yeah, this is really complicated to remember, and that's why we got the expression, well, basically if a equals e, then basically f prime of x is equal to e to the x. That's if a equals e, that's because basically f prime of 0 is equal to 1. So that's why we had this number. But anyways, to get an easier expression for a is not equal to e, well, we could just use our natural log rules. Basically, if we have any number, if we have, let's say, a equals e to the, let's say, ey, using our natural logs definition, basically y is going to be equal to, well, ln e, or log base e to the a. I mean, this is a. This is a. So basically, log base e to the a. You see my other video, natural logs. Basic definition here is if you have any number equals ey, then y would equal to ln a and whatnot. So basically, we have this expression right here. This is y is ln a. So a is equal to e ln a. So now, yeah. So now if we have, let's say, f of x is equal to a to the x, and we know that any number can be written like this. You can see my video on natural logs to see of how all these rules from. It's pretty useful. So basically, so we're going to have, this is going to equal to, well, e ln a all times x. And now we know the derivative of all this. We can do derivative using chain rule. So chain rule is going to be really useful. Yeah, you see my other video on the derivation of it, but it's one of the most useful things you can learn in all of calculus. So basically, the derivative now is going to be equal to, well, using chain rule, the derivative of the top. So this is going to be equal to d over dx is ln a x, the whole thing, which equals to, yeah, this one's going to equal to, well, yeah, this is e to the anything is going to equal to itself, so it's going to equal to e ln a x, and then this is going to be times it by, well, basically the derivative of the inside. Remember my chain rule, I use derivative outside, and then you do the derivative inside. So then we do, well, d over dx of basically ln a all times x. And then this basically, well, this simplifies to, well, if you have e ln a, this is just equal to a. So then we could just simplify this part here. So we're going to go equals to a, because this thing right here is equal to a. This will have a to the x times by the derivative of this. Well, basically derivative of ln ax. This is just a constant. This is not just any constant. So just derivative of any constant times x is just going to be that constant. So we're just going to have ln a. So this is using chain rule. Yeah. So basically we just derived the expression for it. So basically, yeah, f prime of x equals ax times ln a, where f of x is equal to a to the x. So we just derived an expression here. If we compare the two from before here, if we compare these ones, then basically what it's saying is ln a is equal to limit to 0 of a to the h minus 1 over h, and it also equals to f prime of 0. Well, we'll test it out. What is f prime of 0? We'll just put it in. F prime of 0 is equal to, well, a to the 0 times ln a. This is just 1, so it just equals ln a. And this is all correct. So basically, yeah, this is an easy way of deriving it. So this is just much more easier to remember. Just using, you can even derive it easily. Just remember this little rule. Any number could be written as e ln a. Alright, so basically, yeah, if you're gonna do an example, let's go where a equals 2. So in this case, let's say fx is equal to 2 to the x. Then the derivative is just basically gonna equal to 2x times ln 2. And if you put in a calculator, this equals to, yes, if you put in a calculator, let's just go ln of 2. This is equal to, well, yeah, 0.63147. Yeah, so this equals 2x times 0.6931, keeps going on. And this is actually similar to that video, the part 1 of the series, where, yeah, this is basically similar to before. Yeah, and if you put that limit we had before, let's say we had, let's say 2, let's pick it as a small number, 0.001 minus 1 divided by 0.001, that's h, right? So just, and it's, yeah, it's getting close to, well, this number here, 0.6931, and it's getting close to it. So basically, yeah, this is similar to that other one. So we're good here. And similarly for ex, for example, a equals 3, basically f prime of x is equal to 3x, and then the derivative is just equal to 3x times ln 3. And this one's just going to be equal to, well, ln 3 is equal to, yeah, 1.09 whatever. So yeah, we got, yeah, basically, yeah, we have similar to before. Yeah, and these numbers are similar to my other video, which just using the definition derivative and whatnot. So basically, yeah, we have an easy expression to get any what's it called, any exponential function, to get the derivative of it. Well, hopefully you learned, and well, stay tuned for another math easy solution.